Okay, good. Here I go. Now, there was a factor and a remainder theorem we saw earlier, right? But that was actually written for x minus something. We don't quite have that. It turns out, though, you could actually follow the same kind of steps. And I wrote it here. Basically, you get these results. That if you take this polynomial and divide it by this, you can figure out actually what that remainder is. It's not terrible. It just turns out to be this. Not only that, from here, what you actually get is this, excuse me, ax minus b is a factor of this exactly when or if and only if this is 0. That's just immediate from here. That's actually what we get here. It's just, I wanted to point this out. I thought it'd be interesting to bring this up. So, okay, so let's do another example. Okay, so again, let me just say this. So again, we have a sort of remainder and factor theorem for this special case. When you're dividing by ax minus b. Again, we're assuming a is not 0. I guess technically we're also assuming b is not 0, because if b were 0, you wouldn't have to do this process. Not to say it would be wrong to, it just wouldn't be necessary. So if you're dividing by a monomial, that's simple. But we definitely have a is not 0, so this is okay to do. Right. So again, all this is saying is we could take the thing we're dividing by and evaluate it at b over a to get the remainder. What is the quotient? You would have to divide. You could figure out the remainder ahead of time, and because you can figure out the remainder, you can figure out if you have a. All right, let's do another example. So here we have this thing. We're going to divide by 3x minus 5. And right away, we can calculate the remainder. Right? This is our capital F, which is our little f here. The remainder is the dividend evaluated at b. So we're evaluating at 5 over 3. And in this calculation, I did it using Desmos calculator. You end up getting this. So this is going to be our remainder. Right away, that tells you something. That tells you this is not going to be a factor of this. Okay. Let's have fun anyway. Let's divide. And yes, there was a lot more calculation I showed earlier. I mean, the calculation there was just showing you why you can do this and why it works. But maybe I did show more than necessary. I don't know, but I think it's fun to go through with those sometimes. So anyway, we're going to divide both sides by 3. We're going to divide each of these by 3. And really, the calculation earlier, I guess it was good that I did it because it shows you why you can. And that's what I'm doing here. I'm just dividing by 3. See? Because the leading coefficient here is 3, right? So I'm dividing that by 3. That's what I'm doing here. When you divide a polynomial by 3, you divide each term by 3, term by term. From here, you get this. Notice I also put in an extra term here, right? There's no x squared term here. There's no term of the form x squared. Right? We have degree 4. We have to have everything in between, so to say. So it has to be written in standard form, meaning the powers of x are decreasing as you go from left to right. But we also need every term there. We don't have the x squared term. No big deal. I put 0 in. You could put it up here, but it's not going to change anything. 0 divided by 3 is still 0. So we have this problem to do. Okay, so let's do it. Now again, it's just synthetic division. I know it seems kind of, how do I say this? I guess it does seem intimidating. I understand that because you have these fractions here. But the idea is still the same. We have minus 5/3. Minus 5/3. 5/3 goes here. These coefficients go in the top row, as you can see. So from here, right, 5/3, you have the 1, that's the coefficient of this, leading coefficient. 4/3 goes here, 0, right, that's a placeholder, 3. Now, the 1 comes down. Wait, let me get that. What do we do, right? We multiply. 5/3 times 1 is 1. That goes up here. Then we add. 4/3 and 5/3, that's 9/3. 9/3 is 3, so we get this. And we do this, then we do the same thing, right? We repeat. Although we repeat on this number. 5/3 times 3, that's 5. Put it here and add. 0 and 5 is 5. 5/3 times 5, well, that's 25/3. We add 3 and 25/3. If you were to add them 3 here, you can write that as 9/3. Right? You have to have a common denominator. When you add, as you can see, you get 34/3. Right? 3, remember, here, let me write it out actually. Right? You just multiply and divide by 3, you get 9/3, as you can see. I mean, that's a 9. It doesn't look pretty, I know, but bear with me. So we get 9/3. I mean, I guess we could have also kept the fractions here if you wanted to. That's easier. Kept the fractions in here. You could have kept these fractions. That's fine. So we have 9/3 plus 25/3. That's 25 plus 9, 34/3. Multiply 5/3 by 34/3. Get this. Right? 5 times 34 is 170. 3 times 3 is 9. And now we add. For 2, right? 2, remember, right? That's equal to 18/9. So what do? We add here, and we get 188/9. I know it's not the remainder. Bear with me. We're not quite done yet. Well, you can probably see that from the calculation here. So what does this all tell us? Well, this is our quotient. This is the coefficients of it, right? Its degree is 3, 1 less than our dividend. So our quotient is this. The last number here, the last thing here, is the remainder. And then now what we get is, this was our dividend, right? We have this is equal to this thing, the divisor, times the quotient plus the remainder. Again, remember how we divided by 3 at the beginning? We're going to multiply both sides by 3. That's how I got from here to here. I multiplied both sides by 3. So if I multiply the left-hand side by 3, we get what we started with. You can see. You get 3 times this, you distribute. That's how you get 3x minus 5. And we have 3 times this, which is our remainder. I mean, I know you might be wondering, why did we have to multiply both sides by 3? Well, we divided by 3 initially, right? We multiply then to get back to the original problem. I mean, if this remainder here happened to be 0, then for q of x, we could probably try factoring this further. Although this is degree 3, that might be tricky. So I guess we don't have to do that. Okay. Again, I'm not going to ask you to, well, let me not go there. Okay, so what I was going to do now, as you can see on the, as you probably just saw on the next slide, I was going to let everyone here try some problems. I figured it'd be good to do that, for practice. Okay. So let's do that. Okay. So again, these are the ones that you're going to do.